Okay, so we're gonna get started. In terms of announcements, I accidentally posted the wrong room for office hours. It's not 3041 Kemper, which is my office. It's actually 67 Kemper, which is in the basement of the CSIF. We're trying out a new room this quarter, which is why I accidentally had some old data, old information on there. So stop by there if you need help. Some of you guys have been having trouble getting VirtualBox set up. The main issue that I've encountered with people having problems is that they didn't give their virtual machine enough memory. So like by default, VirtualBox might start off with like 1 gig, but you probably want more than 1 gig for your virtual machine. So generally, I recommend trying to give it about like half of your available memory if it's for it to be able to run well. So if you have like 8 gigabytes, give it something like 4. If you have 16, give it something like 8, and it'll perform a lot better for you. Yeah.
I feel like right now I have 2 gigs, but it's running very slowly. Can I change it or do I need to uninstall it?
Yeah, you can change it. All you have to do is after you open the virtual machine, or open up just VirtualBox, make sure your virtual machine is powered off, and then go on to settings, and then system, and then just up the memory. Yeah.
If you choose to instead of downloading VirtualBox SSH into the Kemper computers, will that be an issue because we can't use CLine?
So you really only need to access the computers to be able to run your code. So you can do all of the editing on your own personal machines, and then transfer the files over to the CSIF or some other computer, compile there, and then run.
Okay, that won't be an issue.
Yeah, so that shouldn't be an issue at all.
You don't have to code in Vim.
You don't have to code in Vim or any of the applications that are available there. You can write in whatever your editor you feel like. One other thing. Oh yeah, I forgot to mention on Tuesday, but when you interact with me, make sure that you keep introducing yourself until I know your name. That just helps me associate your face with you. And also make sure if you ever want to maybe get a letter of recommendation from me someday in the future, that I get to know you a little bit, because it's really hard to say more than you took my class and you did good if all I know is that you took my class and you did good. Right? So if you're ever seeking some potential letter of recommendation from your instructors, make sure that you're talking with them. Final thing is, again, if you're coming from 32B and you want this class to flow as smoothly as possible, I would highly recommend taking ECS 34 first. It will make this go a lot easier. If you do decide to stick around, the best things that I can tell you to do are do read up on C, especially focusing on pointers. Most of the things should be fairly easy to pick up, like for loops, if statements, arrays, and like. But pointers and dynamic memory management are the hardest things in C++ and in C, and they're the areas that most of your mistakes will come in. And if you do need help on those areas or help on any area, just stop by office hours a lot. Be there like every day and be talking with me so you can get help on whatever it is that you're confused on. Maybe you might be like, I have this statement in Python. How the heck would I do the equivalent thing in C? We can totally go over that. But you need to be like really, really active and putting a lot of extra work to be able to understand or to be able to write the C code. You'll also need to pick up C++, but that won't show up until the end of the quarter. And we won't be doing like really anything advanced, just basic classes for the most part. And even for the first part of C, it's really that you just know basic C, not that you know anything incredibly complicated. We won't be using anything too complex. Yeah.
I can't find on Canvas the instructions for the assignments.
Yeah, I know I need to put those up. I copied them from an old class, and apparently I had the assignments there. I'm planning on getting them up probably today for you to work on. Okay, so let's get back into C unless you guys have any questions. So loops, fairly easy. There are 3 different types, but essentially they're all more or less the same thing. So there is a while loop, which looks basically like a while loop in Python, except you do need the parentheses. No difference. There is also a do while loop, And the do while loop looks like this. You say do whatever it is that you want to do while some condition holds. And then we follow this with a semicolon. So here we might have, again, index is less than the number of iterations. The difference between a while and a do while loop is the number of times that they're executed. So a while loop is 0 or more times, and a do while loop is 1 or more times. This is because of where the condition is checked. At the while loop, it's checked at the top of the loop. So if the condition failed right away, you would never enter the loop. With the do while loop, the condition is checked at the bottom of the loop, so you're always going to go through its body at least once. So in choosing between these two, it's do you want to do it 0 or more times, while loop, 1 or more times, do while loop. Any questions here? Yeah. Okay, the question is, what's the difference between index plus plus and plus plus index? They are 100% identical as long as they're the only expression on that line. So if you have plus plus index and index plus plus, right? So, oh gosh. Maybe between, we have a new function void, difference between pre and post increment. Oh, the light? Too bright? Sure, absolutely. Thanks for reminding me about that. Better? So if here we have int a is equal to 1 and b is equal to 1, and again, you can declare multiple variables on the same line, just separate them by commas. If you do plus plus a, this is the pre-increment. And if you do b plus plus, which is a post increment, they are identical if the only expression being done, right? So you wouldn't see any difference. The only time that you start to see different behavior is if they're part of a larger expression. So over here, we might have C, and which is equal to 10, and D, which is equal to 10. Now, here, what the pre-increment is essentially doing is basically like A plus equals 1, and this is doing B plus equals 1. Just one more than what you are. If, however, we put them as part of a larger expression, like C is equal to plus plus A plus 2, because this is a pre-increment, the increment happens first. So essentially, if we broke this down into a couple of different lines, this would be something like, so after we do this expression, first we add 1 to A, so A ends up being equal to 3, because we already incremented it before, right? And then we do the 3 plus 2, or maybe we should do 3 plus C. So now we do 3 plus C to end up getting 13 for C. The increment happened first. Does that make sense? Yeah, it kind of is like order of operations things, like the pre-increment happens first, so you add 1 to it first. So this is essentially doing something like A plus equals 1, right? And then C is equal to A plus C, right? This makes A equal to 3, and then over here we now have C is equal to 3 plus 10, which is our 13. If, however, we do D is equal to B plus 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 C, we use the original value of B in the expression, And then after the expression has been evaluated, then we'll add 1 to it. So in this case, B is still going to end up being equal to 3, but C will be equal to, D will be equal to 12. The effect of this operation is essentially doing D, oops, not D, I want D here. D is equal to B plus D, and then doing B plus equals 1. So it's post, it happens afterwards. Yeah?
B equals 3 or B equals 2?
We already added 1 up here.
Okay.
Right, so B started as 1, so now 1 became 2. Then we're going to add 1 more, so B is going to become 3.
Okay, but the expression still keeps it as B equals.
Right, so if you look at line 34, the equivalent lines broken up are these 2 lines. Notice that we do the adding of 1 to B beforehand, right? So this is D is equal to B's current value, which is 2, plus D's value, which is 10, which is going to be equal to 12.
Okay.
And then we go and add 1 to B. So this gets really confusing when you start doing these more complicated expressions. So I recommend just don't do them. And then everyone won't be confused, right? If you're doing B++ or plus plus B, do it on its own line. Just as an aside, you can also do some other really weird things where you could do something like D is equal to B plus equals 7 plus 9 plus 6. Right? And so the evaluation of B being plus equaled, right? You'll do like the 7 plus 9, add that to B. B's value will be updated, then it'll be added to 6, and then we'll store that result into D. I don't recommend writing things like this. They're just syntactically legal. Any other questions? The final type of loop is the for loop, which is probably the one that you're going to be using the most often. And it's essentially a while loop where there's certain spots. So the general format for the for loop is it's for, and then you have initialize, condition, update. And so these things look like for like int I equals 0, I less than num iterations, plus plus I, and then we can do our printing. So notice if we go back to the while loop, they're basically the same thing, except notice this part where I did the initialization outside the loop, I've done it inside the loop, right? This part here in the initialize statement, it only runs a single time, and it's always only run once. We then check the condition, just like we would check with the while loop. If it holds true, we're going to go into the body. Then we do all of the code in the body. And then we go and we do the update step. In this case, the plus plus I. Any questions on the for loop? The major, so continue and break both exist in C, and they behave very, very similarly to the way that they behave in Python, right? Break, leave the loop that you're currently in. Continue to the next iteration. In Python, what happens if you continue inside of a while loop? Or what's the difference between continuing inside of a while loop in Python versus continuing inside of a while loop in a for loop? Continuing inside of a while loop in Python versus continuing inside of a for loop. Right? So so here we might have something like, again, int I is equal to 0, you know, while I is less than 10. Then down here we might have plus plus I. Then over here we might say like if I is mod 2 is equal to 0, continue. Versus, and then down here we'll do our printing. So printf %d /ni versus doing this inside of a for loop. What's void mean again? No return. Fantastic. So here, this would look like for int I less than 10 plus plus I. Same thing here. Yeah.
And the purpose of putting these all within functions is just to kind of separate it for us, right? There's no.
So remember, all C code has to appear inside functions. You can't not put it inside functions. There's a small smattering of things that can appear outside of functions, but like 98% of it must appear inside of functions. The only things that you're going to see appear outside of functions are comments, which can go anywhere. The includes, if you need to include, some file to be able to do something, and if you have global variables, which you're not allowed to use in the class. So you're not going to have anything.
I more meant like when we're implementing these into our own code, right? Like we want to implement a while loop, we don't have to make like a void do while. We can just go within a function.
Yeah, I mean, your for loop can be placed inside of any other function. And for loops can be placed inside for loops, can be placed inside for loops, can be placed inside while loops, can be placed inside if statements, right? Same things. I'm just breaking these apart to kind of like list out the topic. So what's the difference between these two? Yeah.
So why would be an infinite loop and just
The,
number because it has an increment versus.
correct. So this while loop, this is an infinite loop. Because do you guys remember what continue does? What's continue do in Python? In a while loop? Yeah?
Go back to the beginning and then run it again.
Yeah, it goes back to the top of the loop. We check the condition. If it still holds true, we're going to go do it again, right? So notice, if I get down here, I is 0. Is 0 less than 10? Yes, so we enter the loop. 0 mod 2, what's it equal to? 0, so it's equal. So we continue, where do we go? Back to the top. Oh, is 0 less than 10? Yep, all over again. And we're stuck here inside this infinite loop, never printing out anything, right? Now, what do for loops do, though, in Python? What do continues do in a for loop in Python? You guys have used continue in Python, correct? It's go to the next iteration. So it's kind of the same idea here in C as well. When we continue, we go to the update code, and we'll run the update code, which will cause us to go to the next iteration. We'll then check our condition. We'll now have moved from 0 to 1, and then we'll be like, well, 1 divided by 2 is not equal to 0, so we won't continue, and we'll print out all the odd numbers, right? We'll reach the next iteration. So continue basically runs update, then go to top of loop. Yeah?
Wouldn't that be fine in the while loop if we just move the increment to the top?
Yeah, I mean, like, if we move the increment up to the top, yeah, it would be fine. And a lot of times, though, the update conditions, like go to next iteration, they tend to appear at the bottom of your code. And so if you had the plus plus I at the top, the problem you would have is you would never do 0, right? Which is something that we want to have happen. But yeah, I just want to point out this common error that people make all the time. Yes?
Are all for loops in C, are they all iterator based? Is there like
There's no element-based for loops in C++. They're all index-based, right? Any other questions? And again, loops can appear inside loops, can appear inside loops, can appear inside loops. Nothing crazy about that, just like it can happen in Python. You can also do multiple values being created inside the for loop, and you can also just I should also point out that in the for loop, wherever it went to, I had a for loop here, right? So over here, initialize and update are optional. So you don't have to have them. They can be left blank. Right? So it would just be like semicolon, semicolon. So like, you know, an example of something silly. You could out here do something like int I is equal to 0, and then we can get rid of this, and we could get rid of that, and then we could do plus plus I here. Essentially the same thing, right? You can also do multiple updates, so you could also do something like we could just do int I here, and we can initialize a variable that we have declared outside. So here we could say I equals 0 down here. This is useful if you need the variable after the for loop, because in this version of the for loop, I only exists up until the end of these curly brackets. So if you try to do something like this again, you can't, because I only exists up until here. So if you need your index for whatever reason afterwards, you have to declare it outside the loop. You can also do multiple updates. So here we might have like, we'll probably put that back in here. So like int I equals 0, y equals 1, and here we could do like printf %d and have I and y, and then over here we could put our plus plus I, and you can do something like y plus equals 7. So you can do multiple updates in that statement. They just have to be like a single C expression. Any questions before we finish talking about loops? Okay. So if statements look really similar to the way that they look in Python, so you can do like if age is less than 2, printf, you are a baby. Right? But instead of elif, it's else if. So else if age is less than 5, printf, you are a toddler. Else, if age is less than, 13, you are a child, and so on. The curly brackets denote, though, what belongs to that if or else if statement, not the indentation, right? So you could like basically write this statement all in one hideously ugly line, and it'll still work, but it's a nightmare to read. So do still continue to use good indentation. And then again, else is just else, printf, you are an adult. Any questions here? Don't forget our semicolons. Yeah, one more. Sound good? Okay. I guess the next thing that we need to talk about are like static arrays, and then we need to talk about dynamic arrays and memory management, which is the whole pointer topic. So you've kind of seen these static arrays briefly before. So like void print static array. So over here, if you want to pass an array of some type, you have to say whatever its type is. So maybe this is one of ints, right? And then you might have values, but you then put a square bracket. This is essentially saying an array of some length. We don't know how big it is, but it should be one that's declared statically. So arrays don't keep track of how big they are. So you always have to pass in some extra variable to keep track of how long it is. So you might have int length, how long it is, and then our simple for loop for I equals 0, I less than length, printf %d. So you might have something like array at %d is equal to %d slash n, and then I, and then values at I. And I forgot to include IOStream, or STAO. Yeah?
In your words, can't you just like for I colon the array and then print out star I?
So the type of for loop that you're talking about, the element-based for loop, it's in C++, but not in basic C as far as I know. But maybe things have been changed since I last looked. Any questions here? Yeah.
So what is the bracket percent and D mean?
So it's literally the letters A, R, bracket, format holder for an integer, square bracket. So here, right, the I's value will be filled into this %d. So we're going to see printed out array at 0 is equal to whatever its value. Array at 1 is equal to whatever its value is. The AR square brackets aren't doing anything different. If you just want to display some kind of constant text, right, you just write it in there.
So in this situation, we assume there is array and the array have a lot of elements, right?
Yeah, so if we want to maybe say call it, right, we might have void like array, example. And then over here, I might say like I want an it called values, and then it might have, say, 3 things in it, right? And just to be a little bit lazy, we might just do something like for I equals 0, I less than 3, because that's how big it is. Again, zero-based indexing is also used in C. You'd say like values at I is equal to I plus 1 times 2. And then if we want to use our function, we would say print static array, and we would pass in values, which is our array, and then we'd pass in its length, which is 3. And then it'll go print it out. So one of the things about these statically allocated arrays is once you say you have an array of that size, it's always that size. And its size cannot change. So when we made values here, it's 3 big. If we want to add new elements to it, too bad. If we need to like have fewer elements, too bad. You can sort of remove elements by just reducing the length, right? For example, if I said print static array, maybe we'll just change this like int AR length is equal to, say, 7. And then over here we can do AR length and then AR length. We could call print static array values, and we could just do 2. And what do you think this is going to do? only print the first two elements, right? So if I want to like remove elements, I just kind of have to get them to the end of the list and then tell you that the list is shorter than it really is. But if I wanted to create more space in my array, I'm out of luck. Any questions here? You can also have multi-dimensional arrays. And if you want to declare a multi-dimensional array, we might do something like double matrix, and maybe we have a 3x7 matrix. And now it's a 3x7. You can keep going. So we can go like 3x7x9 by 34. You can have as many dimensions as you want. You're just listing the size of each of the dimensions as you go along. But I'm only going to do 2 for this example. And then over here, we might say, int num rows is actually equal to 3, and num calls is equal to 7, so that we can change this a little bit easier. Num rows, num calls. And then we might say something like, for int, maybe we should probably see this as an example. So we might create another function over here, like void fill matrix with random numbers. And now here's kind of the weird thing about C. When you have a multi-dimensional array, you have to specify the size of all of the dimensions but the first. Again, you have to specify the size of all the dimensions but the first. So over here, if I have my matrix, I don't have to say how many rows it has, but I'll always have to say how many columns it has. So in this case, our example has 7. And it's only ever going to work with arrays that are any number of rows where there's 7 elements per column, which, as you're probably thinking, this seems stupid and very restrictive, right? What happens if all of a sudden I need to have one that has 8 elements per row? Well, now you have to write a new function. 10 elements per row, new function. 12 elements per row, new function, right? Even though the code inside the body will be identical. And we'll talk about how we can get around that in a second.
If it's less than.
You can do less than, that would be fine, but you'd still have that extra. So you would still have to pass in an array of that specified dimension, so it'd still have to be that size. But you could use a larger matrix and then just say it's shorter, right? But you'd still have to actually allocate that much space. So we'll show you an example in a minute. So over here, matrix, so int num rows, int num calls. So randomness is pound include. Is it? I think it's in random is in, which one is it? stdlib. Lib.h. We might also want something like int min val, int max val. So over here, right, here's our for loop. For row is equal to 0. Row is less than num rows. For call is equal to 0. Call is less than num calls. Then over here, we could say fill matrix with, or not, oops, our matrix at row call is equal to rand. So rand produces a random value essentially between like 0 and the largest possible random number that can ever be produced. So if we want to confine it to be between min value and max value, we have to know what the range of numbers needs to be. So in this case, we could do something like this. Min val plus rand mod. Make sure this happens in the right order that I want it to. Something like max val minus min val. So max val minus bin val controls the range of numbers. So for example, if I wanted to produce a number between 0, I think we actually need plus 1. Because let's say I wanted to produce a number between 0 and 10, right? That's 10 possible values. So if we take our max value as 10, 10 minus our min value would be 0, right? So 10 minus 0 would be 10. And if I just modded a number by 10, what are the possible values that I can get? 0 to 9, so add 1 to get between 0 and 10, right? If instead I wanted a value between, say, 10 and 20, so again, min value is now 10 and max value is 20, 20 minus our min value gives us 10, right? And then again, if you mod by 10, you'd only get a value between 0 and 9. But again, plus 1, so we're now 11. When we mod, we get a value between 0 and a value between 0 and 10. And then we can add the min value, that 10. So 10 plus a number between 0 and 10 is going to give you a number between 10 and 20. So this is how you do random numbers in C++ or in C. But again, we won't be dealing with randomness. This is just to show you what's going on. So we filled up our matrix. And at this point, we'd actually be done. We wouldn't need to return anything because matrix is essentially a pointer. And again, we'll talk about pointers is pointing to this area in memory. And so something that might be really helpful for understanding what's going on is to look at a website called Python Tutor, which oddly enough has stuff for visualizing C code. So over here, we might have main, and we need to pound include. Oh, we need to probably add one more function to help see this through. So fill matrix with random numbers. Here's our matrix, and then we'll fill in the entire thing right now, num rows, num calls. And what's the smallest value you want to be able to produce? Sure, 0. Maybe we can also do something like maybe between like -5 and what's your largest value? 10. Sure, 10. And we'll fill this value. We probably want one more function to print out our array. So we're probably going to have here void print matrix. And again, it always needs to be something. Oops, I actually need to change this to be integers because the code I gave you here was for ints, not for doubles. Int matrix, int num rows, int num calls. And then over here again, this would be bracket 7. And then our for loop is pretty easy. For row equals 0 row less than the num rows. For call equals 0 call less than num calls. Printf %d space matrix at row call. And then once we reach the end of the row, print out a new row. So let's try putting all of this into Python Tutor. And then over here, we'll just need to call multidim example. And we need to put in our pound includes, a semicolon here. So we need both of these. And we probably also want to initialize our random number generator, which we do this with a call of srand, and then you can give it some constant value, and we'll always get the same random numbers every single time. So let's visualize our execution. Okay, so over here, we initialize the random number generator. We call our function, right? So over here, we have num rows and num columns. They get filled in with their value. We now create our matrix, which I don't know why it's not showing it because that would be really useful. And maybe it can't actually. Okay, it doo-dooed apparently. So we can't really see what's going on in here. So as a reminder, a callback back to Tuesday, what do I need to put into my header file if I want to be able to use this code in other files? Right? If I want to be able to use this function in another file, what do I have to do? We have to create a declaration for that function and put it into the header file. So we'll put all of these into our header file. And again, this allows us to declare them in any order. Again, the header file is just the signature of the function without the body. And as a cool thing, you can click on this, do Alt-Enter, and then split into declaration and definition, and it'll write the declaration for you. So you don't have to keep always doing that. So if I pop back over into main, I can now include static array.h, and then over here in main, we'll just comment this all out. You can highlight it all and just say control/. It's all commented out now. And then we can say, what did I call it? Multi-dim example. Oh, and it seems like we probably have a segmentation fault somewhere. So what should we do? We should totally run the debugger. Let's see how I screwed up. Oh, did I not call print? I think I forgot to call print, which is actually what's happening. We filled it with random numbers, then probably we should print that matrix. Matrix, num rows, num calls. And you can see that we printed it out. It didn't line up quite nicely. That's why it looks a little bit uneven. So that's why things don't seem to be the same number of elements. But you can see we're printing out the values here, and it seems to be working correctly. Right? We could, if we wanted to, again, as long as our matrix has the correct size, we can lie to the function and say it's smaller. Maybe, oh, it's only really a 2 by 3. And if we do that, we probably want to printf a new line here so that we can distinguish between the two. We're only going to see the first 2 rows of the matrix and the first 3 elements in each row. We're going to smaller. But again, the matrix would always have to be the same size. Any questions here about static arrays? What's the difference between an array of characters and a string? Mm-hmm.
Does one of them have to do with having the null element at the end?
Yeah, one of them has to do with the null element. Which one?
The character string? Or
The string.
Array?
No, the string. So a string is an array of characters that ends with a null character. So if your array of characters does not end with a null character, it is not a string. Does that make sense? Okay. There are some very useful functions in string.h, for example, getting the length of a string, or for copying strings. And I highly recommend that you check out that library. And if we have time, we'll go back and we'll do something interesting where we'll implement some of the simple functions that are there. Yeah?
So the matrix initialize is getting modified with the functions, but it's not passing a pointer.
It is a pointer, though. Right? If you look back over here, you can see matrix is a pointer even though it poo-pooed. Right? You can see its type. So it is a pointer, but it's a different way of declaring a pointer.
So in the parameters, it's not necessary to be a pointer to matrix.
I mean, so our matrix here, is matrix really a type? No, matrix is a multidimensional array of integers, right? So matrix itself, what it is, it's a pointer to a multidimensional array. So it is a pointer. So like its type is technically something like an integer pointer to an array that's like 3 by 7. It's a really weird type. Yeah, Mira?
Oh no, I was sorry.
Okay, so let's do the big old pointer talk, which probably means I need to get out a piece of paper and pen, and we're going to draw things. And if you get confused, if you have questions, stop, ask. Your life will be much, much better for them. Also, this won't show up on the recording because I'm drawing over here. And I don't have a cool touchscreen thing to draw, and if I draw in paint, it'll be a horrible, horrible mess. Okay. So, I guess we can leave that discussion for a little bit. So, here's the simple thing. Every variable lives in memory. And every location in memory has an address. Therefore, every variable has an address. Sound good? Addresses are simply numbers. So there's address 0, address 1, address 2, address 3, address 4, address 5, all the way on until the very, very highest address that your computer can represent. Cool here? So over here, if we have some simple variables, we might have something like our ints x is equal to 5, y is equal to 9, and a is equal to 12. So if we look over here in memory, we're going to have our variable names. They have values. And then they also have addresses. For right now, all the addresses that I'm going to make up are completely random and arbitrary and have no particular meaning except I just made up that number. So if you ever ask, where did that address came from? I just made it up. Cool? So over here we have x, y, and a. And then over here, they have values 5, 9, 12. And maybe he lives in memory at location 100, 205, and 232 for A. Right? Again, the address is completely made up, completely arbitrary. If you want to know what the address of a variable is, you put the ampersand in front of it. So if I say ampersand x, how I always read this statement in my head is not ampersand x. This is the address of x. And this is how you should read it as well. Again, this is the address of x. And ampersand itself you should always read as the address of in your head. Right? So if I ask for the address of x, what is it?
100.
Just 100. If I ask for the address of y, what is it? It's just 205, right? If I ask for the address of y, Oh yeah, my bad. I wanted A here. A, it's right. It's 232. If I ask for the address of x plus 7, that's equal to 107, right? There are some technicalities with the pointer arithmetic, but we'll get into them when you need to know about them. Any questions here so far?
Move that up a bit.
Any questions so far? Yeah. They do have a type, which we'll get to in a moment. But the key takeaway here is that addresses, they really are just numbers, right? They're no more complicated than that. But their type of it is a pointer to that element. Any questions about address up? So now, here's where things maybe start to get confusing. And, oops. Probably because the light went off. Yeah.
Okay. Switch to the previous paper.
Once. Okay, hold on. Let's see if this is gonna work. Yeah.
Yeah. So at the bottom line, you write the address of x plus 7. So does it mean you change the address of x?
So if I do this, if I do x plus 12, what do I get? 17. After I do this expression, what's x's value? 5, right? Because it didn't say x equals anything. Now, in this statement down here, did I set an assignment? No, so this is not just changing x's address. The way that you can kind of read this is 7 integers past x, right? The address 7 elements down, right? Because you can kind of think about it. If you live on a street, and let's say the streets are labeled like 1, 2, 3, 4, like for the addresses for the buildings, right? If you're currently at house 3, and you do, say, house 3 plus 7, what do you get? 10, right? Which is, 7 houses past the house you're currently at. Same ideas here. Any other questions? Okay, so let's talk about what a pointer is. A pointer is a variable that holds an address. That's all it is. Pointer is a variable that holds an address. I also forgot to mention that you cannot do this, but we've kind of already talked about it. You cannot ask for the address of y. Why? I mean, it doesn't even make sense. Again, you can ask for what's your house's address. I live at 123 some street, but you can't then ask what's the address of your house's address, right? No way of saying that. So that's bad. It's a bad question to ask. Because again, you're like, what's the address of y? If you read it that way. The way that you declare a pointer is just type you want to point to, followed by an asterisk. So over here, if we go back to our example where we have integers a who's equal to 5, b that's equal to 20, c that's equal to, say, 13, and then again over here we have name, value, address. And when you're working with pointers, until you get really, really confident with them, doing something like this will save you so much heartache later on if you write out some made-up address. Then you have an idea of what's supposed to be going on. So again, we have A, B, and C here. They're 5, 20, and 13. And again, some made-up addresses. Again, completely made up. Now what I can say is, well, I want a variable to be able to hold, say, A's address. So I could say int star PA is equal to the address of A. So again, this creates a brand new variable named PA. It might live at address 400. What value does it have? 100, right? Because PA is equal to A's address. Any questions here? Yeah.
So instead of 2A or a star A, always just A's address, right?
Yeah, so PA, right, what it's going to hold, its value is A's address. If you look at A's address,
Oh, I see.
it's 100. So PA holds A's address. Yes?
You could change the value of A, but you couldn't change the value of the address, right?
Correct. You can change A's value, but you cannot change where A lives. Right? So you can change, like, it's like your apartment, right? You can't move your apartment building, but you can change what's inside your apartment. Any other questions? Right? We might also do like integer pointer, PB is equal to the address of B. And if for whatever reason you want to declare multiple pointers on the same line, you have to write an additional star over here. So PC is equal to the address of C. I tend not to declare multiple pointers on the same line because of this, because I think it's pretty weird just to see like this random star floating over here. But if you leave off this star, PC's type is just int, which is kind of weird. With no, if we don't put the star here, PC is just an int. The types won't match because we'll have integer pointer and int types don't line up. But now, put the star here, it is a pointer. So here we have PB and PC. What's, maybe they're again like 500 and 600. 1 second. What's PB's value? And PC's value? Yeah, go ahead.
So placing the star next to the value or next to the type is not important, right?
Like again, in C, white space really doesn't matter.
Okay.
So again, like I could have written this with no white space at all. Like no white space at all in this line, and it'll still work. Any other questions? Yeah, in the back. I can't hear your question.
So if you wanted PC on the same line, you just do the asterisk. If you put it a line below, you still need the asterisk.
So if we put it, are you saying you finished this line with a comma or a semicolon in your question?
What did you do with the PA?
Oh, there should have been a semicolon here.
So what did you finish PB with a semicolon?
So if we finished PB with a semicolon, then we would need to say int stars, PC. Right? So over here, again, I can now do things like this. If I wanted to, I could say PA is equal to the address of, say, B. And what am I going to get? What's going to happen? Yeah.
The value of PA will change to 200.
Correct, right? The value of PA, it should be equal to B's address. So we'll change PA's value from 100 to 200. Right? Nothing crazy going on there. Now, the next operation, and I think this is some of the reason people start to get confused a lot with pointers, is that the asterisk has multiple meanings. When you put the asterisk in front of a type, it means it's a pointer to that type. And some of the ways that it can help with pointers is if you read it backwards. PA is a pointer to an integer. PB is a pointer to an integer. PC is a pointer to an integer, right? Instead of saying integer pointer PA, right? It just reads a little bit nicer if you go right to left a lot of times with pointers. Now, after the variable's declaration, if you put a star in front of the variable, it's a dereference, and you'll get that variable's value. So, star pointer is called means dereference pointer, which just means get the value at the address that pointer points to. So, at this point in time, if I do star PC, what this says is get the value that PC points to. So PC, where does it point to? Well, it points to 300. Go to address 300 and get the value that's there. So we get 13. If we do star PB, again, this says get the value that PB points to. So PB, where does it point to? It points to address 200. So go to address 200 and get the value that is there. So we get 20. Any questions about the dereference operator? Yeah?
Are you allowed to dereference as much as you want, or is it like a one-time?
You cannot dereference as much as you want. You can only dereference as many times as there are stars on that type. So over here, PC, or say like PB, right, it only has a single star, so we can only dereference it once. Something like A, it has 0 stars, so attempting to dereference it is an error. Yeah?
So I couldn't find a difference between how you make it a pointer and dereference it. It looks exactly the same.
I know, and I think that's where a lot of the confusion comes from. Notice that on this line right here, I'm declaring a new variable PA, or I should say define a new variable. I'm making a new variable. At this point in time on this line, am I making a new variable? No, so now it's a dereference. Go to that location in memory and get the value that's there. It's the only way that I can think about explaining it. Is a lot of times is, because I tend not to write them on multiple lines, another way of thinking about it is if you see the star next to a type, that means you're declaring this variable to be a pointer to this type. If you see a star and there's no type on that line, right? There's no type in front of that variable. That means dereference that variable and get its value. Someone had a question, I think? Yeah.
When you dereference something, can you also update the value, and then does it just need to be the same type that the pointer was?
Yes, exactly. We can use pointers to modify the values of the things that they point to. And we're going to show that in one moment. And you're also correct that just in general, the type on the left-hand side of the equal sign needs to pretty much always be equal to the type on the right-hand side. So if you want to, if you have an int on the right, you're going to need an int on the left. If you have a double on the right, you kind of need a double on the left. The exception is there are some castings where you can like cast a double to an integer and store, it'll transform it automatically for you. Yeah.
So if you had another pointer that stores the address of PA, which in turn stores the address of
We're gonna get to that in one moment, so just hold on. So that's when people start to get really lost. But yes, you can do that, where you have pointers to pointers, to pointers to pointers to pointers to pointers to something. So over here, we can also use the pointer to modify the value of a variable. So if we say something like star PA is equal to 99, what this says to do is go to the address in memory that PA points to and change its value to 99. So if we look at PA, where does it point to? 200, right? Again, don't do like the intuition in your head. It points to address 200. So we're going to go to address 200 and change the value that's there to 99.
Wait, wasn't? I thought that PA was pointing to the address of A. Oh.
Right, we had that line in between. Does this make sense? You can also do something like star PC is equal to star PB. What does this say to do in English?
change the value of C.
Okay, that's what the effect is going to happen, But what does it say to do? What does the actual line of code say to do? Because you're using the intuition that you know what they're pointing to, right? But again, if you couldn't see this, and I just gave you some arbitrary names for these pointers,
The pointer of PC should equal the pointer of PB.
almost there. Yeah.
The value of PC becomes the value of PB.
So if you said the value of PC becomes the value of PB, you're saying you want to change PC from 300 to 200? There was another hand. Everest?
Change the value that PC points to the value that PB points to.
Correct, right? And if you're able to read these statements in English, it will also make your life a lot easier. You need to kind of develop the skill of being able to back translate into English what the code statement is, right? So this says change what PC points to be equal to what PB points to. Sound good, right? So now let's follow that. So first off, we might want to figure out, well, what is the value that PB points to? So over here we go to PB. Where does PB point to? Again, don't utilize the fact of this other information. What does it say that PB points to? To address 200, to the variable is address 200. So we should go where? To 200 and get the value that is there, which is 99. So now we take the 99 and we want to copy that value to wherever PC points to. So now we look at PC. So we've gotten this value, which is the 99. So take that value 99 and go to wherever PC points to and put it there. So what does PC point to? 300. So we go to address 300 and we change the value that's there to be 99. Does this make sense? Yeah.
Is that like equivalent to C equals 99?
So yes, this will end up having the same effect that C equals 99 in this example. I really want to stress in this example, right? Because there are times later on where that may not be true, depending on what other code has been executed. Yes?
You're still recording, right?
I'm still recording. I have no idea how good the audio is going to be, or whether it's going to pick it up or not.
Okay.
So I'm glad you're here.
Okay.
Yeah, this is. I just don't have like an iPad or something to draw easily on. Any other questions? Okay, we got about like one more thing to talk about with pointers, and hopefully we'll have time to get through it. Otherwise, we'll finish on Tuesday. But again, here's our example: A equals 5, B equals 6, C equals 23. And again, we have our name, we have our value, and we have our address. So, and I'm using ints all the time just for convenience, but you can totally have pointers to characters and pointers to doubles and pointers to pretty much anything. I'm just being lazy. Maybe we'll do some examples of that on Monday with pointers to other things. So here you have A, B, and C, 5, 6, and 23. And he might be at address 256, 379, and 182. Right? When we do something like this, integer pointer P1 is equal to the address of A, what does this do in memory? Which memory is over here?
P1 points to the address of A.
Right, so create a new variable, P1. It might be at address 579, and its value should be equal to the address of A, which is 256. Now, we said that we can have pointers to any type of variable. What happens if we would like a pointer to P1? What would its type be? int star star, right? If you want a pointer to something, it's always one more star than its type. Since P1's type is int star, we need a int star star. So we can do int star star pp2 is equal to the address of p1. So I create a new variable called pp2. It has maybe at address 600. What value does it have? 579, right?
Oh.
Because, I think you just misread it. Yeah, 579 because that is the address of P1. Now, let's say, again, you can dereference a variable as many times as it has stars. Star star pp2 is equal to 13. What does this say to do in English?
Change the value of what PP2 points to.
2 times. Yeah, 2 times, right? So we need to do the dereferencing twice. So the first time that we dereference pp2, where do we go to? Right? This part right here says what? Just if we look at this portion with only 1 star.
Value of P1.
Or I should say, just this portion right here. What does this portion say to do in English?
Go to the value that PP2 points to.
Go to where pp2 points to, right? So where does ppp point to? 579. So we go to 579 and we get the value that's there, which is the 256. So this portion of the expression right here, what does it evaluate to?
P1.
256, right? The same value as P1, right? Now we go and we do 1 more star. So we're currently at 256. So now we say go to which address? Go to 256 and then set the value that's there to be Any questions? Yeah.
So I know it's a lot different when you're explaining it and we're looking like, oh yeah, that makes sense. But I feel like if I was writing code, I wouldn't be able to just like do this straightforwardly. So in your like ECS 30 or the 3060 folder, are there practice problems on there?
There are a lot of examples, and like especially in the ECS 30 folder, much more so than the 36B. And we'll probably get to hopefully some on Monday, but I don't want to do more than 3 lectures. Any other questions? So again, another way to also kind of think about things in terms of matching this up is every time, again, you write a star in front of the variable, you need to remove a star from this variable's type. So we put 2 stars here. So what is the type of this expression? So what's PP2's type? Integer star star, right? So I put 2 stars in there. So every star you have in the expression, you remove a star from the type. So the type of this expression is going to be just integer. What happens if we do this? Star pp2 is equal to address of p. What does this say to do? Change whatever p2 points to be equal to the address of b. So over here, we're going to follow that. Go to where PPP points to. So go to address 579 and change the value that's there to be equal to b's address, which is 379. So that's now 379. So now if I do star P1, what do I get? Right? This says go to where P1 points to and get the value that's there. Go to where P1 points to. Where does P1 point to? 379. Go to address 379. The value that's there is 6. Right? So notice in all these operations, I have never changed the address of any single variable. Right? I've only ever changed values. And for the most part, you're pretty limited by that rule. You can't change where a variable is stored at for the most part. Until we get to dynamic memory. Yeah. But we did this line of code right here. Right? P1 did originally point to A's address. But when we did this line of code, we said go to where PP2 points to and change its value to be the address of B. So again, go to location 579 and change its value to be B's address, 379. What variable happens to be at address 579? What variable's there?
6.
So what variable's at address 579? P1, right? So now P1, right, its value is 379, which is the address of B. So we've now made it so that B points to, or that P1 now points to B in that prior line. Okay, guys, I'll see you on Thursday. Stop by if you want more on